Greetings, the Astro 30 here yet again, and I got this dropped off to me today, early this morning. This is a Nakamichi Amplifier1, which is the only information I've got on this thing, but it is a stereo amplifier with speakers A and B output. And down there it says harmonic time alignment amplifier, whatever the hell that means. So apparently we've got a listen monitor switch over here, which I believe is for selecting the inputs. There's a headphone socket there. CD direct, not sure what that does. Speakers A and B select, on off, bass, tone in, tone off, tone defeat. Treble, an audio mute function. I don't know if that mutes the audio totally or just drops it down by 20 decibels. I'll find that out later. And the output volume control, which is just a pot. I put this probably to around the mid to late 80s, maybe early 90s. It's really hard to tell, not without looking it up, of course. Now the complaint on this is when it's playing an audio signal, the speaker protector tends to mute the speakers occasionally. Now I don't know too much information on how he's got the setup wide, what the impedance of the speakers is he's using. Is he using both A and B at the same time, which will halve the total resistance of the speakers, assuming their impedances are the same? Is he using 4 ohm speakers on the output and using both A and B, which would take the impedance load to the amplifier down to 2 ohms. Now there's a lot of amplifiers that don't even test to see if they're stable at 2 ohms. Most are not even designed to run at 2 ohms. So putting a 2 ohm load across it could have weird results. So these are the things I don't know. And as to why the DC protector is operating and muting the speakers, well, it could be a dried out capacitor in the RC filter of the speaker protector circuit. But I'm going to have to see if I can find a schematic for this first and go from there. But we'll have a quick look at what's on the back panel. Right, there's a lot of analog inputs and outputs. Got the phono, I think that's phono. Yeah, phono up here. You can select whether it's moving magnetic or moving coil, which is nice. CD direct, that's what that switch is for. So you just connect the CD player directly up to those inputs. Plus all your normal line ins and outs, tape in, tape out. There's actually can do 2 tape decks, which is okay. Really large banana style output connectors, which I do not like. I hate these things with a passion. And yeah, they're kind of nasty, and sometimes you can't get a wire to make good contact with a stupid binding post behind it. Although these do have a little cutout hole in the top here, so I'm assuming if you put the wire through there it makes it a lot better. The other ones that you have to actually wind them out to expose the hole are the ones I don't like. These ones aren't so bad, I suppose. That's for their system remote output, which goes to tape deck 1, tape deck 2 and a tuner, so the remote of the amplifier can control it. I'm surprised they don't have one for the CD player, but alright. And a switched 240 volt AC outlet. So that comes off the main power switch of the amplifier, so you can turn another device in the system on or off. So that's a quick look at the back of it. Right, as I don't know anything about this amplifier, he does say it works, so it's obviously been plugged in. But for my own sanity, I've got it plugged into my dim bulb currently, just to make sure that there's no major malfunction with the main transformer. So if I turn the dim bulb on, power switch is off, the dim bulb grew bright for a second, that LED is flashing, and a relay just clicked. So that's the DC protect relay engaging. So yeah, there was a little bit of inrush current there. So what I'm going to do now is I'm just going to measure what the DC offset is on each of the channel outputs. The speakers are currently disconnected at the moment. Amplifier is still on, so I'll turn speaker A on, which is where the multimeter is connected to, across the left channel. And there's bugger all there. It's like 1 millivolt or so. So I'll switch to the right hand channel. Right hand channel is connected, turn the speakers on. It's a little higher on that side, but it's only like 6 millivolt. It's nothing really to worry about. So I know it's safe to plug this directly into the wall, so that's what I'm going to do. When it's plugged into the wall, hopefully I don't blow anything up today like I did the other day. Blew up a transformer. All good so far. And do I still have the speakers turned off? Yes I do. It's more like 13 millivolts now, 12, something like that, on the right hand channel when the dim bulb's not in circuit. I'll switch back to the left and measure that. And the survey says the left channel is around 8 millivolts. Okay, so we know that the amplifier is so far functioning to a point. So now what we need to do is get it on a dummy load and oscilloscope and signal source and just see what the output looks like. Now this might be a little bit more awkward because the amplifier is kind of in the way of the oscilloscope screen, although no, it looks like I can still get a shot of it. Alright, the 8 ohm dummy load's hooked up to the left channel, oscilloscope's on times 10 on the probe, going into channel A, channel 1. So now I've got to turn this on, I'll give it a bit of volume. Right, nothing yet. I don't know what I'm actually selected to. Yeah, okay. It would help if CD Direct was off. So yeah, we've got an output. It's clipping there. So let's just change the voltage per division so we can see the trace. So it's not what I wanted, I wanted the other way. There we go. It looks relatively clean. We're at 1 kilohertz, so alright, back that off. It's clipping there. That's nice output. We're in times 10 mode on this probe, but we're in times 1 on the oscilloscope. That's 29.3 volts RMS out and 85.6 peak to peak, which is about 110 watts RMS. That's not too shabby. Okay, so I need to figure out where the speaker protector is causing an issue. So I need to change my frequency generator to a bass frequency, so we'll start at 100 Hertz. Okay. Nothing happened. Okay, so I'll wind that down to 60 Hertz. Protector's not doing anything. Alright, 30 Hertz. No, I cannot make it do anything there, so 10 Hertz. No. Alright, so I guess I should check the right channel then. Alright, right hand channel is hooked up. I need to switch my input. There we go. Nothing seems to be happening at 210 Hertz. So I'll put this back to a kilohertz and I'll just see what the power output is. at that voltage, at that frequency. About the same as the left channel, so that's fine. So I can't see 20 Hertz, I can't see a fault. Can you? It seems to be functioning fine. So I don't know what the issue is. 10 Hertz. Nope, I don't understand really what the issue is here. 1 Hertz. There we go. Right, well, it obviously doesn't like going down to 1 Hertz. So I suppose 1 Hertz looks like a DC to it, so I'll just take the tone control network out. Yep, still does it. Okay, so let's turn it on and turn the bass full up. Okay, so we'll go up. There we go, I'm moving it around. Alright, 19 Hertz it seems fine and happy with. Hertz with the bass at full, yeah, it doesn't like it. So technically speaking, this amplifier should be able to happily reproduce down to 10 Hertz without affecting it, but that is with the volume up quite significantly. So I'm just wondering if there's a problem with the DC detect part of the circuit, which is just like an RC filter or a resistor and a capacitor. Capacitor could have gone dry, who knows, but I guess the next thing to do would be to open it up and have a visual inspection of the insides, plus it's kind of interesting. There's no guarantee that I'll be able to fix this, but at least we've got some content for the channel. However, before I get too happy doing that, I'll just test how the amplifier performs into a load, i.e. a proper load, a speaker. There goes the relay. Give it a bit of volume. I don't hear any unusual noises at the moment, so that's good. Play a track. Sometime today will be good. There it goes. Okay, I'm going to pause that a second. Nothing unusual is happening. The amplifier seems to be performing how it should. I wasn't driving it that hard. So the bass was up full and it was outputting fine into my speaker. So it appears that this doesn't really have that much of a fault. However, what I am going to do is I'm going to use an oscillator now, and I'm going to go down into the real bass register frequencies here and sweep around on it and just see if it causes the thing to, you know, cut out. Alright, I've got a sweep generator loaded in the browser, so I'll just play the sweep. That's 1 hertz to 60 hertz. Alright. Do that with the bass full up now. Jesus Christ. Well, the camera won't do that justice, but that was pretty vibrating. Yeah, I can't make this thing go into DC protect mode, so honestly, I don't think there's anything wrong with it. See, this is the thing with electronics and fault finding. You get a complaint on a unit, and then you've got to try and duplicate that complaint. And sometimes it can be awfully difficult. And also, does that occur more regularly after the amplifier has been running for a while and it's getting nice and hot? Yeah, you know, these are the things you need to consider. But as I said, I can't get this thing to fault itself. Like, turn that bass back down, because that was really overdriving my speaker. That seems fine to me, so what I'll do is I'll change that from 60 Hertz to an end frequency of 20 Hertz. I forgot that was not the bass, that's not the bass part, that's a treble. I mean, it seems fine to me. Alright, so I'll stop that and I'll change the end frequency now to 10 Hertz. I've got a blinding light in my face. Nothing unusual is happening. That switch is a bit. How you doing? Yeah, I can't fault the amplifier. Alright, so what does this mean now? That means I'm probably going to have to leave this on soak test with a frequency going into a dummy load, of course, not going into a speaker like that, because it will kill the speaker after a while, plus it's annoying. And just, you know, let it go on, say 10 Hertz, 20 Hertz, 30 Hertz, 40 Hertz, bass control full up at, say, I don't know, 1/3 of its volume, close to half its volume, something like that, and just let it run for like 5-10 minutes and see if the speaker protector starts kicking in and out, and see if I can get it to do more frequently, because at the moment I can't see anything physically wrong with the amplifier. And before the end of this video, I am going to take the top off and we are going to have a look inside, so yeah, don't worry about that. But I want to do some more testing first before taking it apart. So yeah, I'll get to doing that. I'll just leave it on a dummy load into an oscilloscope so I can see what's going on, and yeah, we'll go from there. Well, I managed to get it to do it quite frequently, and it's starting to smell in here because my dummy load is sitting at the back of a wooden desk and it's red hot. So yeah, it took about 5 minutes to do it, but it's doing it. So yeah, my dummy load's not capable of of driving it properly. I need to put that dummy load up on top of something so it's not burning the desk. Now it doesn't even take much for it to do it. So it does have something to do with heat. The amplifier is getting warm, so what I'm going to do is I'm going to let that go for a while so everything cools down. Pop the top off and we'll just have a visual inspection inside. I wanted to see what the resistance of my dummy load was when it was red hot. Apparently 0. I don't know if I've just destroyed that or not, but yeah, that's still red hot. So here's a look inside the unit. That's the power amplifier stage and what looks like a micro PC. I think it's 1324 or something, one of those NEC devices that give you DC speaker protection. It looks like that's what it is, and it also looks like the bottom comes off. So that makes it handy. So, yeah, so I've got a bunch of electrolytic capacitors around here. So I'd really need to find the schematic to this. However, it looks like my dummy load has gone short circuit. So I finally blew it up. It smells like a frickin' barbecue in here. Yep, I found the schematic for it, amazingly. The protector uses a micro PC 1237H, which is an NEC device. It has a 100 microfarad 16 volt capacitor. Here, pin 2 should be the input. So this is a 16 volt bipolar 100 microfarad capacitor there. 16 volts seems a little bit low to me. And a 100k current limiting resistor up here, which comes off of one channel, and there's another one joined to it that comes off the other channel. Going into this, this forms an RC network here. That's as much as I can zoom that in. So yeah, these two resistors, 100k resistors here, R306 left, R306 right, and C304 form a RC filter that stops any of the AC frequency signals falsely triggering the circuit. There's a little bit of a bleed resistor there as well. From what I can see, this is not unusual, and it still smells like a barbecue in here. And damn, it smells good. It smells like wood fire burner barbecue. Anyway, that's beside the point. That's the capacitor in question there. That little jobby there. There's only one, so it uses it for both sides. That's fine. I mean, the unit itself's got a decent sized heatsink on it. And yeah, it wasn't even that hot. My load was red hot. Nice large filter capacitors here. Huge iron core power transformer, which is nice. So I don't think there's anything actually electrically wrong with the amplifier. I think it's more like user error. I mean, to put it politely. With the bottom panel removed, which defeats the feet that are on the bottom of it, so we've got to be careful of that when turning it back over onto its right side up. I can't see anything joint wise that's obvious except a little bit of heat stress around some of these pins here. Nothing looks like a bad solder joint. Doesn't appear to be any cracked or broken solder joints. Oh, so at some point someone's replaced a component and a pad's lifted right off. So they've bridged it to where it went, which is up to here. I didn't do that. So yeah, that's probably the first thing I've noticed about this, but other than that, everything else looks pretty normal to me. There's no terrible joints, no loose joints. Everything still seems like it's solid. So yeah, there's nothing really obvious jumping out at me. I mean, both boards that I have access to the bottom of, looks like a few joints could be touched up here and there, especially on the power supply board way over there. That's the main power supply board. A few joints on that could probably be fixed. However, the main power amplifier board looks fine to me, so yeah. And I'm still waiting for my dummy load to cool down to see if its resistance comes back up. Alright, through the course of testing I've got a new dummy load hooked up across the output. Got a couple of 100 watt 4 ohm resistors. Got a square wave going in at 10 Hz. It looks absolute crap on the screen. That's to be expected. The bass is full up. I believe tone's not defeated. No, it's not. I can't fault it. Unfortunately, the dummy load I built a year ago is now dead. Dead short circuit, that is. So that's cool now. So it's not hot anymore, and the resistance has not come back up. So I've actually burnt the resistors. Well, not burnt them out, but somehow they managed to short. Usually resistors go open circuit, not short circuit. So that'll be something to look at later and pull it apart and see what actually the carnage is on side. Well, there's your problem. I've just opened up the dummy load and that resistor's actually cracked in half. You can see the ceramic on the inside. It's actually melted the wiring as well. So this is now completely stuffed, and well, one wire's actually got so hot it's come unsoldered. What was that for? That's going to this output socket. So yeah, it's melted the ground lead to the BNC socket. It's melted the leads together, and I wonder if that's why it's shorting. They got really red hot and I can't even get them apart now. Yeah, it's completely obliterated this. This was not a good design, obviously. For lower powers, yeah, maybe, but these wires were actually in contact with the hot surface, so it eventually would cause problems. So this whole entire dummy load is shot. There's I can't really repair this without rewiring the whole damn thing. However, I am going to make a new dummy load, a little bit better and more robust than this. So, because everything's melted together, this lid doesn't even come off very far. So all the wiring has got so hot, it's just become one. Right, so now we know what's wrong with that. Well, as we can see, the NAC is now back together, and there's a reason for that. Newsflash, I was correct. There is absolutely nothing wrong with this amplifier. I've just been told recently a little bit more information on how he managed to get the thing to be faulty. He says, and I quote, that when this control, the volume, is wound up to about 66%, or just a little over 2/3, then it starts acting up. Yeah, well, there's a reason for that. Take your average input signal of 2 volt peak to peak, and that control wound up to here. The amplifier is already into clipping, and as I tested, it takes 3 Hz with the bass flat, the control around about where it is now, for it to start clicking in and out. So that would make sense because the amplifier is already into distortion now, and that 3 Hz signal looks like DC. So it's actually working as it's designed, and it's working properly as designed. So I'm kind of a little annoyed now that it turns out to be, as I already stated, user error, to put it politely. So this will go back as NFNC. That means no fault, no charge. So I won't be making any money on the repair of this thing because, well, I didn't do anything. I sold it a couple of joints, but that was only just for longevity. I'm not really going to charge for that. It's not worth the effort. But yeah, I am kind of annoyed that that's what the result is. Although I do have some other stuff from the same guy that I'm at least 99% sure are actually faulty. So there'll be stuff that I will have to repair, but this one, no, it's working fine. It's working as it's designed. And I'm not going to go modify the DC Protect circuit by putting a larger capacitor value there or whatever, just so he can think that he can get like more than, 66% of the control out of it. Because, as I said, 2 volt in at that volume is already into clipping, so we're already reached our maximum power by that point. It's not going to produce any more past that point, except shitloads of distortion. So it's not designed to be run that high in power. So yeah, I'm really kind of annoyed because that was kind of a time waster. However, it's content for the channel. We got to look at an old retro amplifier which does actually sound pretty good. So what I'll do to end this video is I'll hook up a couple of speakers, a sound source, and just close it out that way. Okay, it's probably about the best I can fit it on the desk like that. A bit swamped. Turn it on. Give it some volume and play a track. Yes, it's working fine. So yeah, I'm going to end this video here, and I just want to say thank you for watching. If you enjoyed it, please remember to go down there below and rate, comment and subscribe if you haven't done so already. Anyway, I will see you in the next video. This is the Astro Theist saying see ya. Have a great day.
Biggest stickers.